Welcome. There's a moment in every C++ developer's journey where they realize they've been doing something the hard way. For many, that moment is about practices, not features. You can know every modern feature and still write code that's hard to maintain. In this lesson, we're covering the habits that matter: clarity, safety, ownership, and API design. These aren't rules imposed from outside, they're patterns that make your code easier to debug, review, and extend. Let's get into it. The most important practice: prefer clarity over cleverness. On the left, a compact version, the score function loops through values, adding each one, if it's positive, using a ternary operator. It works. But the rule, only count positive values, is buried inside the ternary. On the right, a clearer version. We extract the predicate. Is positive returns whether a value is greater than 0. Sum positive loops through values, checks is positive, and adds matching values. It's slightly longer, but the intent is obvious. The predicate is testable independently, and anyone reading the code can see the business rule immediately. Clarity over cleverness. Every time. 5 good defaults that reduce decision fatigue. First, use const by default. If a variable doesn't need to change, mark it const. This communicates intent and catches accidental mutation. Second, use std vector for dynamic lists. It's cache-friendly, well understood, and almost always the right default container. Third, use string view for non-owning text parameters when the lifetime is safe. It avoids unnecessary copies. Fourth, use unique pointer for exclusive ownership. It makes the ownership model explicit in the type system. Fifth, use algorithms over handwritten loops when the intent is clearer. Ranges sort, find, if, transform. They communicate what you're doing, not how. Deviate from these defaults when you have a reason. But start here. 4 design principles. First, make illegal states hard to represent. If a connection requires a host and port, don't default construct a client with empty fields and fix them later through setters. Instead, take a validated connection config in the constructor. The object is either fully valid or doesn't exist. Second, keep classes small and focused. A class that does one thing well is easier to test and reuse than a class that does everything. Third, avoid hidden ownership rules. If a function takes a raw pointer, is the caller responsible for the memory or the callee? Use smart pointers and value types to make this unambiguous. Fourth, minimize global state. Globals create invisible dependencies between unrelated parts of the code. 4 tooling practices. First, compile with strong warnings. Wall, Wextra, and wpedantic catch many bugs before they reach production. Second, run sanitizers in debug builds. Address sanitizer and undefined behavior sanitizer catch memory errors and undefined behavior at runtime. Third, add tests for bug fixes. Every bug you fix is a test you didn't have. Write the test first, then fix the bug. Fourth, format automatically. Use clang format or a similar tool so code style is never a discussion in reviews. The command on screen shows the minimum local build. G++ with C++23, or warnings, debug symbols, and both sanitizers enabled. Treat warnings and sanitizers as part of normal development, not as a cleanup phase at the end. 4 rules for API design. First, make ownership obvious in types and function signatures. If a function returns a unique pointer, it's transferring ownership. If it takes a string view, it's borrowing. The types tell the story. Second, prefer returning values over output parameters. Build label takes a string view and an int, returns a formatted string. Easier to use and test than forcing callers to allocate an output string and pass it by reference. Third, use span and string view for read-only borrowed data when lifetimes are clear. They avoid copies without transferring ownership. Fourth, mark must-check return values with the no-discard attribute. If a function returns an error code or an optional, the caller should never silently ignore it. Borrowed views, span and string view are excellent API tools. Log names takes a span of const strings. Greet takes a string view. Neither function owns the data, the caller retains ownership. This avoids copies and makes the borrowing relationship explicit. But there's a critical constraint. Use borrowed views only when the lifetime is obvious and short. If the callee needs to store the data past the call, caching it, queuing it, or passing it to another thread, a borrowed view is the wrong choice. The view will dangle when the original data is destroyed. In those cases, take ownership, accept a string or a vector by value, and move it into storage. 3 error handling models, each for a different situation. Exceptions. Use them for exceptional failures that should unwind through multiple layers. Constructor failures, out-of-memory conditions, invariant violations. The error propagates automatically until something catches it. STD optional. Use it when no result is a normal outcome and no explanation is needed. A lookup that returns nothing. A pass that finds no match. The caller checks has value and moves on. STD expected. Use it when callers need structured error information. A pass that can fail for multiple reasons. Empty input, invalid digit, overflow. Expected carries the specific error alongside the failure. Match the model to the calling pattern. Don't use exceptions where expected is cleaner. Don't use expected where optional is sufficient. Here's expected in practice. Passport takes a string view and returns expected of int, string. We use from chars to pass the text into an integer. If parsing fails, either an error code or unconsumed characters, we return unexpected with a specific error message. Port must be a decimal number, otherwise we return the passed value. The caller gets either the port number or the error message. Both paths are explicit. The caller can't accidentally ignore the error because expected forces them to check. This pattern works for any validation function where the caller needs to know what went wrong, not just that something failed. Adopt modern features in priority order. First, readability features. Concepts make template constraints explicit. Span and string view make borrowing clear. No discard prevents ignored return values. These are low-risk, high-clarity upgrades. Second, safety features. JThread eliminates manual join calls. Expected makes error handling explicit. Source location replaces preprocessor macros. Third, productivity features. STD format cleans up output code. Ranges replace manual loops. Chrono calendar handles real-world dates. Fourth, architecture features. Modules and coroutines require toolchain support and broader changes. Adopt them when the pain point justifies the investment. The key principle: adopt features that improve readability and correctness first. Architecture-level changes come last. 5 questions for every code review. First, is ownership obvious from the types? Can you tell who owns each object by looking at the signature, unique pointer, shared pointer, value, reference, span? Each communicates a different ownership model. Second, are names describing the business rule, not the mechanics? Sum positive is better than process values. Passport is better than convert string. Third, does the API return a value instead of mutating through an output parameter? Returned values are easier to compose and test. Fourth, are lifetime assumptions explicit for spans, views, pointers, and references? If a function stores a span, the caller must guarantee the data lives long enough. Is that documented? Fifth, would a standard type or algorithm make the code shorter and safer? If you're writing a manual loop that ranges for each already handles, switch. Here's the key takeaway. Simple code is easier to debug, review, and extend. Prefer clarity over cleverness in every decision. Use const by default. Make ownership obvious in types. Return values instead of mutating output parameters. Choose the right error model. Optional for absence, expected for typed errors, exceptions for exceptional failures. Compile with warnings and sanitizers. And in code reviews, ask whether a standard type or algorithm would make the code shorter and safer. These aren't rules for special occasions, they're habits for every day. For next topics, continue with build, debug, and test for CMake, testing frameworks, and debugging workflows. You now have the practices that make modern C++ maintainable. Apply them consistently. Thank you.